Table problem number 2 here, calculator inactive, keep that in mind. Let's look at the table. We have T in minutes, so time in minutes, C of T in ounces in our table. Let's look at the context of the problem here. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time T between 0 and 6 is given by a differentiable function C, where T is measured in minutes. So C is apparently the amount in the coffee cup. So C is standing for coffee. Selected values are given in the table above. All right, part A, use the data in the table to approximate C prime of 3.5. Well, C prime is the derivative, think slope. So if we're trying to find 3.5, then we're going to use the values at 3 and 4. So that's going to be 12, let me label it, always label. C prime of 3.5 equals 12.8 minus 11.2 over 4 minus 3. Notice this is calculator active, but they make it very manageable. 12.8 minus 11.2 is 1.6. 4 minus 3 is 1. So 1.6. Make sure you include units. We're talking about ounces per minute. Ounces were on top, minutes were on the bottom. Show the computations that lead to your answer. We did that, and indicate units of measure. So we're good. You get 1 point for the computation, or the approximation here of 1.6, and you get 1 point for your units. Because remember, anytime they say indicate units of measure, you can guarantee that they're going to be counting a point for units somewhere. Okay, let's look at part B. Is there a time between time 2 and time 4 at which C prime of T equals 2? Well, the setup here should be making you think mean value theorem. We've got an interval of time, and they're asking where the derivative equals 2, so that should be making you think, okay, slope of the secant line is equal to the slope of the tangent line at a point. So let's check and see what the slope between 4, C of 4 minus C of 2 over 4 minus 2. Let's find out what that is. Well, C of 4 is 12.8. C of 2 is 8.8. 4 minus 2 is, of course, 2. 12.8 minus 8.8 is 4. 4 divided by 2 is 2. So you get 1 point for that. You also need to establish, let's look back at the problem here. Remember mean value theorem, we have to be continuous and differentiable. They tell us it's differentiable. So C of T is differentiable. And therefore, C of T is continuous. And with that work there, you can say, therefore, by the mean value theorem, please don't abbreviate. Okay, I know it should make sense that MVT stands for mean value theorem, but they don't like abbreviations because some teachers use different abbreviations than others, so just write it out. Okay, there is at least one time between 2 and 4 for which C prime of T equals 2. Okay, so you get 1 point for showing the work of the slope of the secant line between 4 and 2, and you get 1 point for your conclusion using the mean value theorem. Part C, use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1 over 6 integral from 0 to 6 C of T dt. Using correct units, explain the meaning and the context of the problem. So let's do our midpoint sum with 3 subintervals. So if we're going from 0 to 6, that means we're going to go from 0 to 2, 2 to 4, 4 to 6. So our midpoints are 1, 3, and 5. Like I said, draw all over these tables, guys. They're not going to judge you based on what you have on your paper. They're just looking to see if you got the right answer. So if that helps you, I encourage you to do it, and I really do think that that would help. Okay, midpoint is the one that gets a little tricky. So again, make sure you label it. So 1/6 of 0 to 6 of C of T dt equals 1/6. Midpoint, okay, we're just talking about width of the interval times the height. So that all the intervals are width 2. So really, since they're all the same width, let's make our computations a little bit easier. Pull that 2 out front. And then we've just got the height. So C of 1 is 5.3, C of 3 is 11.2, and C of 5 is 13.8. You'll have to, let's see here, that gives us 1/3 here in front. If we go over here, and oh goodness, they're asking us to add decimals. Oh well, we'll be okay. No. 5, 6, 9, 10. So that's 30.3. And 1/3 of that would be 10.1 ounces. So what does that integral stand for? Anytime you see that fraction there in front, remember that's the average value. So 1/6 integral from 0 to 6 of C dt is the average amount of coffee in the cup over the time interval zero is less than t, which is less than 6 minutes. You get 1 point for your midpoint sum. So for setting it up right here, you get 1 point for your approximation of 10.1. Technically, you do not have to simplify. You could leave it right there. I know we don't like that, but let me just reiterate, if you're not confident in your computations, don't simplify. Okay, don't simplify. And really, I think technically this is also acceptable. Okay? And then you get 1 point for the interpretation, mentioning that it's the average amount. Okay, last part. So we've got 2, 4, 7 points so far. That means we've got 2 points left for this last part. The amount of coffee in the cup in ounces is modeled by B of t is equal to that function. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. Oh, okay. So we had the table up here at the top. Now they're giving us an actual function for the amount of coffee in the cup. So find the rate at which the amount of the cup, coffee in the cup is changing. So they give us the function for the amount. They want to know the rate. So what is that? That's derivative. B prime of t is equal to, well, the derivative of 16 is 0. The derivative of an exponential is the exponential times the derivative of the exponent. So nothing changes, and then we multiply by the derivative of the exponent, which would be negative 0.4. Now, a little quick review on multiplying decimals. So you multiply it like a regular number. 6 times 4 is 24. 4 times 1, that's 6. And we had one number after the decimal. So we move the decimal from here to here. So 6.4 e to the negative 0.4t is our derivative. You get 1 point for the derivative. You get 1 point for plugging in 5. Again, you don't have to do any simplifying right here, but if you want to, you can. Negative 0.4 times 5 is negative 2. You can leave it like that. On the rubric, they got rid of the negative exponent. I really don't think you have to do that. It doesn't say to use units, but again, I want you to be in the habit. It never hurts to have them. This is a rate, so we're talking about the amount over time, so ounces per minute. 1 point for the derivative, 1 point for b prime of 5.